Hey guys, Mr. Bowman here. Today's learning objective is in grey and we're learning to expand single brackets. To start off with, what we want to do is we want to do a quick example just regarding numbers, just to demonstrate how this operation actually works, and then we'll extend that to our algebra as well. So as a starting point, the key word we're looking at is expand. We'll quickly change pen color as well. And expanding is really the process of removing brackets. And that really does focus on algebraic expressions. You don't really need that for regular maths because you can get around it for algebraic expressions. And I suppose how it works. And if you have a look at the example, 2 times 3 plus 2, normally what would happen is you would just do the 2 times the 5, and that would get you to the final answer of the 10. And that's absolutely spot on, nothing wrong with that. But another way to think of it is if you do this 2 times 3, and then if you do 2 times 2, so plus 2 times 2, that's also going to get you to 10. And the latter is more appropriate because if the inside portion, are not like terms, that means you can't actually merge them together to get the 5 like we've done with our first answer. That means you do have to do them separately like we did this in the second answer. Hopefully that makes sense. So it's the process of removing brackets, and the reason it's important is the bit within the brackets, they're not always like terms and we can't always group them together. So let's get into some examples of how that relates to algebra. So let's have a nice simple one, 3 and then in brackets x plus 2. And the issue I've identified, the bit in the bracket, x plus 2, those are not like terms. We can never really merge those together to then times it by 3. So that means we've got to do the timesing by 3 separately. And I call this the rainbow approach. You normally do 2 times 3, and then 3 times x, and then 3 times 2. So that's going to get us to 3x plus 6. And hopefully you can see what I mean when I say the rainbow approach. Up there, though, those top lines do look a bit like a rainbow. And again, these aren't like terms, so we cannot merge them or add them together. And we can get a bit more complicated. We can integrate some negative numbers. So let's say you're negative 2, and then you had 2x minus 1. The same approach applies. You've got negative 2 times 2x, which is negative 4x. And then you've got negative 2 times negative 1, which is positive 2. Same applies there. You can get a bit messier. You can look at fractions. So let's say you got 1/4 of 8x plus 4. You got 1/4 times 8 is going to be 2, and then you got the x, and then you got 1/4 times 4, that's going to be plus 1. So let's change pen colors, let's get into blue, and let's get into some harder ones. We can also start dealing with square numbers. So if you know how to multiply with the algebra, then you'll know how to do all this. So let's go 3xy, and then you've got x plus 2y. Same process, you got 3 times x, which is going to be 3x squared y. And then you've got 3xy times 2y, and that's going to be plus 6xy squared. And we can ramp this up in difficulty really, really quickly. We can get in negatives, we can get in heaps of powers. So let's say we've got negative 2x squared y cubed, and that there is going to be multiplied by 2xy minus 3z squared. We do our multiplication, so we're going to do the first 2 multiplied together. So we've got negative 2 times positive 2, that's going to get us negative 4. We then deal with all the letters alphabetically. We've got x squared times x, that's 3 x's in total. We've then got y cubed and a y, so that's 4 y's. And that completes the first pair. Then we have a look at the second pair. Negative 2 times negative 3, that's going to be positive 6. And then we've got x squared y cubed and z squared, because there's no other similar letters that are the same. And that would be your final answer. Normally for this, hopefully you can see there's a negative expression out front. When there's a negative number out front, sometimes it's best practice to put the positive one there and then do minus that negative part. Some people consider that simpler, but there's no right or wrong way to go about that. And I suppose the very final question we want to look at is sometimes there might be two brackets in the same expression. So let's say we've got 3x and then we've got 4x minus 1, and then we're going to add 3x squared minus 2, for example. So process, we're just going to do that twice. We're going to have to go 3x times 4x, it's going to be 12x squared. We're then going to have to do 3x times negative 1, so it's going to be minus 3x. We then do that for the next one. 3 times x squared, that's going to be plus 3x squared. And then we've got 3 times negative 2, and that's going to be minus 6. We can then group together the x squareds. They can be combined, so that's going to be 15x squared. The 3x, so there's no other x's by themselves, so we'll just put down 3x, and then 6 is the only number. We'll do that as well. So those ones are a bit more complicated. So what I'm going to do is I'm going to pause the video. We're going to go through one unique scenario that's really important to understand. This is a common issue that I see people get wrong, and then once I've done that, we'll get into some practice. We've cleared the top portion, so let's get into question 7. We'll do an easy version of the ones that I see us do wrong all the time, and then we'll do a harder version to back that up. So the issue that I'm seeing, or that I see come up all the time, there's no real number outside the bracket, it's just the negative sign. So hopefully we can see what I mean by that, just the negative sign up front. And the approach to do this, a lot of people just get really confused and end up writing 2x minus 3, and they forget about the minus sign. The minus sign is really important, because in front of that, there's an invisible 1. So that's actually minus 1. And the same approach needs to happen with our expanding. So we need to go negative 1 times negative 1 times 2x is negative 2x, and then negative 1 times 3, positive 3. And you may want to change that so the negative 1 isn't out front, so 3 minus 2x. So that invisible 1, it's really, really important, and it's one that I just see time after time people get wrong. So let's try a harder one. So let's go 3. Oh, we've done 3. Let's go 7x plus 3, and we're going to go minus 4x minus 1. So same process. If you have a look, the second part here, that's identical to what we just did. So what we're going to need to do is we're going to need to add in that invisible 1. Physically draw it in. I find people who don't draw in that 1, they fail to identify that this is one of the scenarios that may cause trouble, and they get math errors as a result. Once we've added the invisible part in, just over there, we can then go ahead and expand. So we've got 7 times x is 7x, 7 times 3, 21. And then we've got negative 1 times 4x is minus 4x. And then we've got negative 1 times negative 1 plus 1. We can then group together the like terms. 7x minus 4x, that's going to get us to 3x, and then we've got 21 plus 1, 22. And then my final bit of advice, don't forget about the invisible 1. So I can't emphasize that enough. People are going to forget about it. It causes a lot of issues when we get to quadratics, so please don't forget about that negative 1. So hopefully you found this video useful. We did 8 questions. We went through expanding, easy all the way to hard. Let's get these notes down. Let's get into heaps and heaps of practice.